Hi everyone in Algebra 2B. Today we are going to be going over your questions that you have on lesson 97B. We're still going to do numbers 18, 19, 20, 25, 27, and 29. So the first thing that I'm going to do for the number 18 is that I'm going to multiply top and bottom by I. When I do that, I'm going to distribute the I, which would become 5i squared minus 2i to the third all over negative I squared. Now, I squared is equivalent to negative 1. So that's going to become 5 times negative 1. And then minus 2, and I cubed is equal to negative I. And again, I squared is going to be negative 1. So that two negatives make a positive. I multiply 5 times negative 1 would be negative 5. Negative 2 times negative I would be plus 2i. And that's your result. Moving on, we're going to look at number 19. So for number 19, the first thing that we're going to do is I'm going to move the square root of z to the other side by subtracting it. Now, in order to get the square root of the square root, I'm going to square both sides, which means on the right-hand side, I need to multiply it by 11 root z. When you square the square root, it gets rid of that square root, so we would just be left with z minus 33 on the left-hand side. On the right-hand side, I have 11 times 11, which is 121. 11 times negative root z would be a negative 11 root z. Negative root z times 11 would be negative 11 root z. And then negative root z times negative root z would be positive z. But if you look at both sides of the equation, we actually have a positive z that would cancel out of both sides. Now I'm going to move the 121 to the other side by subtracting it. Oops. So it'd be negative 33 minus 121, which would give me negative 154. I'm going to add the negative 11 root z's together, which would give me negative 22 root z. I'm going to divide both sides by negative 22, which would give me that root z is equal to 7. Now to get rid of that square root, I'm going to square both sides so that z is equal to 49. But remember, whenever your problem starts with a square root in it, you do have to check your answer. So the square root of 49 minus 33 plus the square root of 49 equals 11. Now 49 minus 33 gives us 16, so that would be the square root of 16. The square root of 49 is 7. Then we know the square root of 16 is 4, so 4 plus 7 is equal to 11, which is correct. So therefore my answer is z is equal to 49. Now moving on, we're going to look at number 20. So the first thing that we're going to do for number 20 is I look at this line and see how far away from the origin is that going. Well, it's going to the left of the origin, which means that it's going negative r, so it's negative 4.00 r. And then it's not going up or down, so that would be plus 0.00 u. Now I'm going to create a right triangle with this other one, which is going to the right of the origin and going up off the x-axis, so both my r and my u are going to be positive. Now to solve for r and u, I'm going to use cosine for r, which would be 4 slant times cosine of 34. And then for y, or for u, I'm going to use sine, so 4 times sine of 34. You're going to use your calculator, so 4 times 34 cosine equals, and you should get 3.32. Then 4 times 34 sine equals, and you would get 2.24. 4. Now both our r and our u are going to be positive, so I'm going to put this over here as positive 3.32r and then plus 2.24u. Now I'm going to have negative 4 and then plus 3.32, which would give me negative 0.68r and then plus 2.24u. And that would be your result. Now moving on to number 25, the first thing that I'm going to do is I'm going to eliminate the denominator. So I'm going to multiply this whole thing by the common denominator, which would be r squared times x plus y. Now, if I multiply this first fraction by r squared x plus y, that means I'd only multiply the a times r squared. So that would be a r squared. Then I'm going to multiply the c by everything. So it'd be minus c r squared times x plus y. And the last fraction, I would only have to multiply by x plus y. Now I'm going to distribute the c r squared, which would give me a r squared minus c r squared x minus c r squared y equals x plus y. Now we're solving for y, so anything that contains a y, I'm going to move to one side, which means I'm going to move the c r squared y to the right-hand side by adding it, and then I'm going to move the x to the other side by subtracting it. So on the left-hand side, I would have a r squared minus c r squared x minus x equals, I got rid of the x, and I'm going to factor out a y, so it'd be y times 1 plus c r squared. So I factored out a y out of both of those terms. Now to get y by itself, you're going to divide by the parentheses, so y is going to be equal to everything that I had on the left-hand side, so ar squared minus cr squared x minus x over 1 plus cr squared. And that solves your answer for y. Now moving on to number 27, we are given that the area of the circle is equal to 49 pi. So that means that we're going to try and find the radius. This would be the radius. And the way you do that is by setting that equal to pi r squared. It's equal to 49 pi. The pi's on both sides are going to cancel. And when you take the square root of r is going to be equal to 7. So that means the radius is 7. Now, if I continued this diagonal, we notice that 2 radii make up the slant or the diameter of the circle. And now I can solve for the length of each side. So each side, it's a square, so each side is going to be of length x. So I would do Pythagorean theorem. X squared plus x squared equals, well, if this is 7 and 7, equals 14 squared. So I have 2x squared is equal to 196. Divide that by 2, x squared is equal to 98. There is no square root of 98, but I can simplify the square root of 98 to 7 root 2. So the length of each side of the square is going to be 7 square root of 2. To find the area of the square, you do length times width. So the length is 7 root 2, and the width is 7 root 2. So when I multiply this, 7 times 7 is 49. Square root of 2 times square root of 2 is 2. So 49 times 2 is 98. That would be centimeters squared, be the area of your square. So you have to use Pythagorean theorem in this one to solve for the lengths of the sides of the square. And then lastly, we're going to look at number 29. So for this one, we have to get from milliliters per second to inches cubed per hour. So what I'm going to start by doing is going from milliliters to liters. Now I know that there's 1,000 milliliters in 1 liter. So my milliliters are going to cancel. Then I know that there's 1 liter in 1,000 cubic centimeters, so centimeters cubed. So my liters are going to cancel. And now I need to go from centimeters to inches. So there's 2.54 centimeters in 1 inch, but don't forget that I have to cube that because the centimeters is cubed. And then I need to get from seconds to hours. So this would be 60 seconds in 1 minute, and then 60 minutes in 1 hour. So I kind of have to squeeze that in, but the minutes cancel, the seconds cancel. So my answer is going to be, well, you should see that the thousands also cancel. So you're left with 400 times 60 squared. So 400, 60, 60 over 2.54. And don't forget that 2.54 is cubed. And that would be inches cubed over hours. And that concludes your questions for lesson 97B. I hope you guys all have a great day. Bye.